Hello, I'm Max. Welcome to my channel. In this video, we are going to make the Flutter app that output a sine wave work on Android. And again, we have already created the app and the FFI plugin in the second video of this series. So if you want to know how the folders was structured or what our native code looks like, you can watch the second video, or you can just follow the link in description to the code on GitHub. Now first, let's install what we need. First, of course, is Flutter. And I have already installed Flutter. And we also need Android toolchain and Android Studio. Okay. And next, of course, we need an editor to edit our code, Visual Studio Code. And with Flutter plugin installed, and since we were going to edit a CMake file most of the time for this video, we are going to need CMake plugin. And to make GStreamer work on Android, we're gonna need GStreamer binary for Android. It's in the GStreamer website. Head over to download, scroll down, there's Android. We're going to use the latest as for now. It's 1.22.6. I've already downloaded. It's here, and I have already extracted to gst-android folder. And after extraction, you'll see 4 folders correspond to 4 architectures supported by GStreamer. In each folder, you'll see a complete library or binary release for this architecture. Okay, first let's try to build it with nothing modified. This is our app. Okay, and okay, let's make it full screen. Okay, apk debug. And it failed. If we see the arrows, if we see into the command, we can see the argument tells us it's using headers in this machine, not inside our GStreamer binaries for Android. Okay, which is not what we want, and we're going to change that. And first, let's go to our folder in app. This is, let's head into native binding. And create a folder, third party, and cp copy the entire folder to here. Okay, and we don't want Git checking out all the files. We want to ignore this folder, and you can always download yourself and extract it and rename it to gst-android. We'll create a git ignore gst-android. Okay, and let's open our CMake file. Okay, and if is this is Android or dash dash underscore underscore Android underscore underscore else and if. And remember, we don't want to use headers in our local machine. So this is the line that uses our local machine, and we want to move it to when it's not Android. Okay, and let's start here. First, let's figure out where our GStreamer binaries are. And since we have 4 architectures, we will need to know which architecture we are building. And let's set first gst folder CMake current source directory, go up a level. Okay, this is where we are, going up this and go into third party and go into gst-android. Okay, third party gst-android and add another variable API suffix set to Android API. And Android API uses different name for ARM, and we will add our checks here and set it correctly. If Android API string equal API v7a, and we will set API suffix to ARM7 v7 ARM7, else if string equal ARM64 v8a, set API suffix to ARM64, else if Android API string equal x86, and we will skip, else if Android API string equal x86 underscore 64, and we will also skip this, and if okay, and we will set gst root to gst folder, and inside that gst folder is our API suffix. Okay, and we gotta include our headers. What we have used is dash of uppercase I. Okay, let's copy that. This is our GStreamer. This is to GStreamer. Okay, and this is our local machine. I think this standard library header, we do not need to reference that. And this is glib header, and this is headers also for glib. Okay, So include directories, gst root, include GStreamer 1.0. Yep. gst root, include glib 2.0, gst root, glib 2.0, and include. Okay. And we also need to set where our libraries are. If we enter one of these folders, let's say ARM64, and it's by the name, it's inside this folder. It's inside lib folder. Let's see what's inside. Yep, this is a lot of compiled libraries. Okay, so link directories, gst root, lib, gst root, and we also need plugins for our GStreamer, which is, oh, let's see if we can find it here. Says root. Seems no. Okay, no matter. I can tell you where to link. Lib and lib GStreamer 1.0. This is where our plugins are. You can see all the files inside here has GST in it, which is our GStreamer plugin libraries. Okay. And how do we link against that? Well, first we can try and see if our library header path was correct. Let's save it, update our package, and build it. Let's see, I think we are getting different arrows, which is a good thing. And we are linking against, where's our, oh, yep, this is where we're linking. Lib, this is our library folder. This is also our library folder. And we have our headers. Oh, seems like this is for heading. This is for linking. And for building, let's see, scroll up. Scrolling up. So building is fine. Okay. Now, okay, seems since we are getting different arrows and the libc symbol arrow was no longer thrown, I think that's a pass. So let's fix our problems. Okay, GStreamer binaries for Android was compiled using NTK build. And since Flutter uses CMake, Let's see what we can do about it. And we are in binaries for ARM64. And in here, let's open share and gst-android and ndk build. And let's open this folder in our Visual Studio Code. Okay. In this folder, we see one template file, one plugins.mk, and one GStreamer 1.0.mk. If you have downloaded GStreamer documents and you have looked into Android tutorials, you see the project will use this template file to generate a file that will be compiled in the final project. So let's copy this to our project. Create gst-android.c.in, paste. And since our pipeline was really simple and we don't need to use any GIO related stuff, we will remove all the code that's GIO related. See GIO, GIO module, GIO, GIO, and GIO header. Okay. And let's see how this was generated. If you understand the grammar, these two with two @ symbols will be replaced. Okay, and the replace behavior was executed in this file, GStreamer 1.0.mk. Okay, let's search this plugins declaration, and we can see this is a command that replaces this one, the @ sign included, with this one. And we can see just up here, this one was equal to this one. Let's search and go up. Okay, now for each plugin, we'll have a function call to this function, and same for register. Okay, let's do that. Let's first define two variables, set empty variables when we define it. Okay, set, and this one. Okay, list append gst plugins. Okay, what we need is, remember there's a plugins.mk, and our plugins are audio test src, audio converts, audio sync, which is all in this, in the first line, categorized as GStreamer plugins core. Okay, let's search that. Audio test src, which is in the first line, I believe. Yep. And audio converts, yep, it's this one. And auto audio sync, which is not here, but no worries. I'm gonna tell you how to find it in documentation and API references, GStreamer plugins. And if we search auto audio sync and open that, And under plugin, it's auto detect. Let's search, and it's in first line as well. So let's copy the entire list. Okay, it's here. Plugins, and we can delete a bunch of stuff that we don't need. First is video. This is not needed. This is what we need. Volume not needed. This is not needed. Pango not needed. Overlay composition, compositor, audio resample is not needed. Config mixer not needed. I think we can also delete this one, and you can play with it. Okay, I'm gonna leave it there. Of course, you can delete them and try it for yourself once we got everything working. Okay, now same as before, we're gonna loop over this list and replace it and append a function call to here to these two variables. Okay. gst-p, this is the variables we can access within each loop, and the list is gst plugins and list append this and replace that with this function call declaration. Yep, this is gst underscore p, and copy paste, and we don't want to overwrite that one. Okay, registration. Okay, and let's use the template file to generate our source file. Configure file gst and android.c.in to CMake current source directory. Name will be gst plugin init android.c. Okay, and this file should also be compiled into our library, and let's put that in a list. Appended source, copy this file name and put the list here. So when this list is empty, no file will be added. Okay, let's see. Let's try to run the project and generate our code. Okay, it's complaining. Okay, let's see. Okay, file is generated, and you can see we are missing this one here. This line is missing. Okay, but we can have a simple fix for that, like so. And let's run that again. And okay, no more squiggle lines. Okay, we can close that. Okay, let's see what it complains. It's complaining is linking complaining. Undefined symbols. GST plugin register. Okay. And let's see what we are missing. And we are, when generating this, we have this libs. And okay, I think where for each plugin we need to link against that using a GST prefix. Okay, let's try to add that. Let's add a list link. Oh, this is append link libs GST prefix and GST p, and we will add this one to when it's not Win32, and again when this is empty, nothing will be added, so we are safe. Okay, let's try that again. Oh, we are already seeing that, right? Okay, red lines here. Okay, libintl. And one good thing about we are using Linux is we can go to lib folder and directly grab the thing we want, and it will tell us which file contains them. What we are missing is libintl, so what we need is intl, as the file name suggested. Okay, let's append to this list. We can put it here. Append link libs intl. Let's see, and the rest is repeating. Let's see what we need. Icon v open ffi. Okay, let's search icon v first. FFI, it's FFI. FFI. And icon V. Icon V is here. Okay, there's icon V. This one, yep. Icon V. Okay, anything else? FFI, G module. And it's G module 2.0. Here, nope, here. Okay, let's see what else. intl we've already added. Okay, let's try that again. Okay, PRCE. Let's see if those lines were kept. No. Yep. PRCE. PRCE2. Guess that's the library name. Yep, PRCE2-8 is in here. Okay, that's all we got. We still have a lot to GST base. Okay, let's see if we can find those lines again. Oh, no. Okay, too many. We are out of luck. Okay, let's start here. GST base, GST base, GST base, GST base, GST base, and GST base, GST base. Okay, okay. I guess the name is GST base. Oh, we'll copy the line as well. So this one. The GST base 1.0. This. Okay, what we have this time, GST audio. Okay, ORC, GST audio. Okay, GST audio 1.0. Oh, bad audio. We want is GST audio. GST audio. Okay, GST audio. Okay, ORC. ORC.0.4. Okay, let's put that AO. Okay, yeah. Okay. ORC is in. Anything else? GST audio. Okay. GST audio. Okay, nothing more. Okay, this time is G-seekable. I think this is GIO. Yep. File create is GIO. File GIO. GST app. Okay, we got two. First is GST app. GST app.1.0. GST app. GST app. G file. This is from GIO. Yep. GIO. Okay. This one. And anything else? file cancel. This is from GIO. Gseekable seek. Okay, let's try that. Okay, we got more. Android lock, and this is from Android. And if we see here, and we see there are two, this variable was used in two places. One of them, it was defined here, and later it was used in here. And we can see a link against log and z. Okay, let's add that. Log and z. Okay. And this, and we got this one, and we can't find anything. Let's find it. And this is all, and this is all, and these libraries are all referencing this function. And this is a standard library functions. And remember, if you remember when we are downloading, we can see our binaries are compiled against NDK version 21. And this one was targeted version 21 as Android SDK version 21. And our binding and our binding plugin are using version 19, which is below 21. So we're gonna change that to 21 and build that again. And it failed, and it tells us the app is compiled against an SDK version below 21, and we're gonna have to set it to 21, like so. Okay, let's build that again. You don't have to update the package this time. Okay, I think it works. Oh, it works. Okay. And by the way, we are building the app for all 4 architectures, and we are using all 4. Okay. Now let's run it. Open our Android emulator. And I'm using a VM, so this Android emulator was a nested VM, so performance hit was expected. And let's run our app. And it crashed. And we maximize this, and we can see the crash was caused by this function, which is called by this function, which is called by this function, and which is the function that we run our main loop. And if we try to comment that line, let's see, it's here, comment this line and build that. Oh, let's try to update our packages and build that again. Okay, it built. Let's try to debug that. And the app works. Okay. And when I was preparing, I was trying to solve this first, but since we're here, let's try to find why our app don't have sound. Besides, we don't have a main loop running. And if you see here on Android, GStreamer uses opensles to output sound and OpenGL for graphics. That's why these two are in category GStreamer plugins sys. And to make sound works, we will have to use this one. And remember, this plugins needs to be declared, registered, and linked against. Okay, let's put that in this list and see if we need to link other libraries. Okay, seems like we need something. Okay, SL is a Android library. Need to link against as well, which is go by name of SLES. Okay, and do that again. Oh, seems it works. And try that again. Oh, okay, we have our audio. Okay, since looks like I was mistaken the whole time. We don't need the main loop at all. Okay, we can comment that out, and maybe we can do some cleanup later. We don't need main loop. Main loop was not required, and let's try and generate that. Generate fi gener Flutter pub run fi gener ffi gen. Oh, we can find our command here and run that. Okay. Oh, yep. Okay, and in our start file, there's no function called run main loop. Yep, and we can remove that. Okay, now we have our main loop now. Oh no, and we got our sine wave now. Let's try that again. Flutter typo, okay. Okay, it works. And let's run that again. And we got our main loop. And if you hear our sine wave was a little bit laggy, you can debug a performance. You can try to improve performance by tweaking your code. But I'm running this in a nested emulator, so I'm not going to dive too deep into that. But we have our sine wave. And one more thing. Since our pipeline was really simple, the libraries, the plugins we are using is very limited. We don't need to link against many plugins in our native code. And if your pipeline was really complicated, you can adjust this accordingly. And you know where to find those plugins, right? And you also know how to find which libraries you need to make these plugins work. Okay? Now, if you want to debug your native code, Visual Studio Code won't work. You need Android Studio. And let's open Android Studio. Let's close all our Visual Studio Code. Okay, close Firefox. Android Studio was in here. Studio. Okay. And this one is our app project. We need to open the Android folder inside our app project. Okay, I select it, hit OK. Open a new window. And okay, the Android folder was opened. If this is the first time you use Android Studio to open the Android folder in your app project, Android Studio will download a lot of things to parse the project's dependencies correctly. Now we have it open and we have everything set up. You can go to left up corner, drop down, packages, and all the things will be listed here. And we can see our native binding.c, which is our C code. Okay, and again, we're gonna put a breakpoint here and hit our debug button. And you can see it's building. Oh, we can also remove the main loop variables in here, but it doesn't matter. We can debug it anyway. Okay, debug has started. And breakpoint was hit. Let's open that first. is audio test src, which is this one. Okay, value before assign is 274. Okay, next line 274, remember. Now is 468. Okay, next is convert 56D. Next 56D 3E0, right? Next is audio sync E69. Next is 028 pipeline 02D and 088 main loop. Well, we don't need, but hey, 169. Next line AB0, right? This is how you debug your native code. Okay, that's it for today. In the final video of this series, we are gonna make it work on iOS. Yep, and see you in the next one.